In this video, we're going to interpret a box plot. So Robin and Marion are arborists and measured the heights of the 312 fledgling saplings in the forest to examine their health and growth. Their data are displayed in the box plot below. Okay. So the first question, well, let's look at the box plot real quick. Okay. Notice we have on the horizontal axis height in centimeters, so that's going to be the height of the trees. Okay. And notice here there's no vertical axis. There's no meaning to the height of any of these values. Okay. The numbers here are corresponding to the height in centimeters. So the height of this is completely arbitrary. Could have made it taller, could have made it smaller. So first we're asked, what is the 5-number summary of the box plot and what does each represent? Okay. So the 5-number summary corresponds to these 5 numbers that are labeled here. Okay. And they're labeled because they're some of them are decimal values, and it's hard to read it exactly from the horizontal axis, but notice this is 4.2, 7.3, etc. Okay. So let's write this list. We list the 5-number summary from smallest to largest. So 4.2, 7.3, 13.2, 25.5, and 28. Now, what do they represent in terms of the data? Well, the leftmost value, 4.2, is the minimum. So that's the smallest height of a sapling. Okay. Might as well jump to 28. 28 is the maximum value. The largest value of a sapling is 28 centimeters. Now, 13.2 we're already very familiar with. That is the median value, which now we also call Q2 for the second quartile. Okay, so the median means that 50% of the data are to the right and 50% of the data are to the left. Okay. Now these two values, which are called the first and third quartile, so we're going to write Q1 and Q3. Quartile meaning 4 pieces, so notice this is broken into 1, 2, 3, 4 equal pieces. They represent 25% of the data is to the left of 7.3. Okay, so we'll just write that down here. 25% of the data is to the left. Also, that means 75% is to the right. Okay, and here at 25.5, that's the third quartile, and that means 75% of the data is to the left of this value. Okay, so these values are the medians of the median. Okay, so if we look at the median and the minimum value, the first quartile is halfway between the two. Now it doesn't look halfway, okay, but remember what we mean by halfway is the number of data points. So there's 25% of the data points are here, 25% are here, the 25 to 50% if we put them in order. Okay, there's another 25% here, and that could be misleading because this box looks bigger, but there's not more data points here. It's just more stretched out, and 75% to the top 100% are in this range. Okay, let's go to the next question. What is the range of heights of the tallest 25% of saplings? Okay, so the tallest 25% would be the top 25%, which is up here. So this is the third quartile, which means 75% is to the left, and again, 25% is to the right. So the range is 25.5 centimeters to 28 centimeters. Next, we're asked, for what value are 50% of the sapling's heights both above and below the value? Well, 50% is the median value, which is Q2. So 50% to the left, 50% to the right. So 13.2 centimeters. Let's look at the next question. What percentage and how many of the 312 saplings are 7.3 centimeters or taller? Okay, so here's 7.3. So here's 7.3. That's the first quartile, so 25% of the sapling's heights are to the left of that, or less than that, and 75% are to the right of that value. So 75% of the saplings are 7.3 centimeters or taller. And notice we're also asked, it said what percentage and how many of the 312 saplings. Okay, so we need to find 75% of 312. So we will take lost my pen. We will take 312 and find 75%. 75 out of every 100 of the 312. So times 75 divided by 100. Notice that's also 3/4. So 234 saplings. Let's look at the next question. Are the number of saplings between 7.3 centimeters and 13.2 centimeters in height greater than, less than, or equal to the number of saplings between 13.2 centimeters and 25.5 centimeters? So let's clean this up a little bit. Okay, so the saplings between 7.3 and 13.2, this range right here, it wants us to compare these values to the number of saplings between 13.2 and 25.5. And I alluded to this question earlier. Okay. So these are our quartiles, and we know that 25% are between 7.3 and 13.2. 25% are the left of here. 50% are to the left of 13.2. So this is 25%. Similarly, this is the 50th percentile. 25.5 is the 75th percentile. So there's also 25% in here. Okay. Relatively, these boxes, it looks like this box is twice as large as this box. Okay, but that's irrelevant with a box plot. What we're really looking for is the length. The box part is telling us this is where the middle 50% of the data lie. Okay, so we were asked, is it greater than, less than, or equal to? And they are equal. And let's just write a brief justification. So from 7.3 to 13.2 is 25% of the data. Okay. And between 13.2 and 25.5% is 25% of the data. And we can get that by noticing that this is the 50th percentile minus the 25th percentile is 25%. And here, just noticing, should have written this in the other. No, we can write it like this. Sorry. The difference between the 75th percentile and the 50th percentile is also 25%. Last question. If we had all the data and made a histogram, would the data be approximately symmetric, right skewed, or left skewed? And how do we know? Okay, so notice half of the data is clustered between 15 and, I'm sorry, not 15, 4.2 and 13.2. Okay, the other half of the data is spread out over a larger range of values. So this tells me that about half is here. Okay, that's not the best graph in the world. I'm not an artist. Okay, about half is here, but this 50% is spread out over a longer range. So let's put the mean right here, or the median. Okay, so there's about 50% here and 50% spread out. So this would be basically because the the median value to the right is longer than this value, it's skewed to the right. So let's justify that. Right skewed. Okay, so we'll say the upper 50% has but we say a larger range of values than the lower 50%. Okay, so that's going to make it more spread to the right. I apologize for this graph. I know it's not the prettiest thing.